Hello everyone and welcome to this video on self-learning topic under the course of U18 EC 407 Digital Design. This course is being taught for the fourth semester Electronics and Communication students. So the first SLD self-learning topic which I have put up is logic gates. This has been taken into consideration because just a small overview, once again recap of the concept of yesterday what you have learned about the logic gates would be discussed over here, because all the logic families would be designed for different logic gates. So you need to have a little bit of concept about logic gates, that is must and should. So we'll start the lecture by uh, giving about the overview of this lecture. Okay. So first we will be giving an introduction to the digital logic gates with the truth table symbols, and then we will be discussing on NAND and NOR gates, which are called as universal gates. So starting the first topic of discussion would be introduction to the logic gates. So what is this um, logic gates, and what is this meant for, and what is its important? Here you can see this. The name is nothing but gate. Gate is general. What a gate will do, gate will either stops or it allows. The same way here there would be different terminology would be used over here, which should be quite similar to the physical gate which would be appearing in our buildings or whatever it is there. So first we'll start with this the names of the logic gates over here. There are logic gates of simple logic gates like AND or NOT. Universal gates are NAND and NOR. And you would be having special gates like XOR and XNOR. These are the total number of gates which are available to realize any logic function. Using of gates, whatever the logic function is been given, whatever the implementation of logic function is there, you can implement this using on it. Obviously, again, when you go for the hierarchy, when you go into the hierarchy of this one, all of the logic gates are implemented by the transistors. Transistors are the major building blocks. Even a simple transistors can function, can used, can be used to implement any logic gate. Like we had in a direct coupled transistor logic. Here, all the transistors are coupled together to give you the output configuration. So in direct coupled transistor logic, we'll be using only the transistors. There won't be any resistors. There won't be any other components used over there. Only the transistors would be used, and there the transistors would be used to take or realize any gate which has been given. So here the transistors are termed as to be fundamental devices. So in generations of computer inventions, now whatever the Pentium processor you are having, it consists of 3 million transistors. I mean to say, if you first thing is that logic gate can implement any logic function. Next one is that any logic gate can be implemented using of what? Transistors. So what we can say is that any logic block is there or any device is there. So if you are having under transistors, then obviously it is sufficient to implement any logic function. Okay. Or that processor will be consisting of only transistors. That's it. There won't be anything else. So nowadays, whatever the chips are being built up, it is having 10 million transistors on a chip, or more than that. Okay. Not deviating much to the topic. Again, when we'll come back to the basic concepts of what are the simple gates over here. There are three simple gates. One is AND gate, OR gate, NOR gate. So AND gate is nothing but when both the inputs are 1, output is 1. So the functionality of AND gate is like that when both the inputs or all the inputs. So both the inputs would be considered in the terms of two input NAND gate. If you are having any number of inputs, so then all the inputs are 1, then the output is 1. Remaining all the cases, when one of the input is low or both the inputs are low or one is low and high, then any number of combinations, the output is what? 0. So this is turned to as AND gate. Similarly, when you take up an OR gate, in the OR gate, if both the inputs are low, what? If both the inputs are low, then only the output is low. So this would be the case. You can see over here, when both the inputs are low, output is low. Remaining all the cases, if one of the input is high or both the inputs are high, whatever the configuration you are having, the output is what? High. And NOT gate is nothing but when you apply 0, output would be 1. When you apply 1, output would be 0. This is about the NOT. So these are the circuit symbols of an given the logic symbol, or we can say the circuit symbols of all these three simple gates. Next comes is the two universal gates. Why they are called as universal gates? NAND and NOR are the two gates such a way that using of these gates, any logic function can be implemented easily using of one specific gate. If you take NAND gate, you can implement AND gate, you can implement OR gate, you can implement NOT gate, you can implement XOR gate, you can implement NOR gate, anything. Or any function given to that one can be implemented easily using of only NAND gates. But this is not the case with the other gates other than the NOR gate, because NAND and NOR are the two universal gates. Using of these two, the functions of that is such a way that it has a very wonderful function that it can be implemented any gate of this. So that's the reason these two gates are called as universal gates. So using of these gates, you can implement any logic function. That's the reason we say it as universal gates. And what is its truth table? NAND gate is not of AND gate. So here N stands for not of AND gate. I can write as AND prime. So in AND gate, when both the inputs are 1, output is 1. So here it would be 0. Remaining all cases, it will be 1. Similarly, OR gate is what? When both the inputs are low, output is what? Low. Remaining all the cases, output is high. So the same thing is been implemented over here. You can see when both the inputs are low, output is high. Remaining all the cases, it is low. Opposite of a OR gate. Exclusive OR gate. This is one more special gate when both the inputs are complement to each other. When both the inputs are same, output is 0. When both the inputs are complement to each other, the output is what? 1. This is about the XOR gate. So using of these gates, we will be we will be taking up transistors and we'll be developing the ICs. So there would be certain ICs developed over here using of this. Now see here, for example, AND gate implementation. Why proving of NAND gate is an universal gate? So you can implement an AND gate using of NAND gate. You can have a connection of this circuit. So one NAND gate, another NAND gate, it will be implementing the function like this way. So this one is a NOT gate. NAND gate converted with a NOT gate, obviously you will get NAND gate. So this is an OR gate, this is a NOT gate. Similarly, using of NOR gates also you can implement OR gate and NAND gate, AND gate and NOT gate. All the gates, in not only these gates, any function can be realized over there. So these are the set of ICs which are being available in the market using of any set of technology. Well, we are discussing the technologies over there. So these are TTL NAND gates. TTL NAND gate is there, TTL AND gate is there, TTL OR gate is there, TTL NOR gate, TTL exclusive OR gate, TTL NOT gate, and this is the you will be having 4 input NAND gate, and this is 5 input NAND gate. Okay. So like this way you can have any number of inputs, and you can use these ICs for your configuration. So here what will be the last, I will be closing my topic with the integration levels. There are different integration levels in the ICs used over here. First, we'll start with small scale integration, where 1 to 10 gates would be there. Medium scale integration, 10 to 100 gates would be there. Large scale integration, 100 to 1000 gates would be there on a chip. And very large scale integration, you would be having more than 10,000 gates would be available. And these are the introduction what we are having in a microprocessors there. During this era, microprocessors were developed. Okay. Anyhow, what I want to have it from this output from this lecture is that, yeah, I think you are able to know the truth table and functionality of all the gates. So there are once again I'm repeating, there are and or not basic gates. There are two universal gates, NAND and NOR, and two special gates, exclusive or unexclusive. Thank you for watching this video. In the next video, we will be discussing on the another self-learning topic. Thank you.